This question says a ball impinges directly upon another ball at rest and it's itself brought to rest by impact. If half of the initial kinetic energy is destroyed in the collision, the coefficient of restitution is. So here neither mass is given nor velocity is given. That means we are required to find both of them. One thing that we know is momentum is conserved. So in the first case, momentum is possessed by only the first ball. In the second case, momentum is possessed by the second ball. And magnitude of momentum before collision is equal to magnitude of momentum after collision. Let P be the momentum. Then kinetic energy before collision, I'll say Ke1 equal to P square by 2m1 because only m1 has momentum or velocity. So kinetic energy after collision is how much? P square by 2m2. Why P square by 2m2? Only because only m2 has velocity, m1 has come to rest. Now the situation says that half of the kinetic energy is lost. So I can say P square by 2m2 equal to half of P square by 2m1. So P square cancels, 2 cancels. From this I get m2 equal to 2m1. Right, so we have a relation between the two masses. So I can say if m1 equal to m, then m2 equal to how much? 2m. So this is the relation between the masses. Now let's find out the relation between velocity. Let u be the initial velocity of the first particle. Then we have m into u equal to 2m into v. So v would be equal to how much? U by 2. Now what all things we know? We know u1 equal to u, u2 equal to 0, v1 equal to 0, v2 equal to u by 2. So coefficient of restitution is v2 minus v1 by u1 minus u2. v2 is u by 2 minus 0, u1 is u minus 0. So that is half. So coefficient of restitution in this case is 0.5. Hope you could follow this. The option for this is option C, 0.5. Thank you very much.